Compute Manager allows you to run, monitor, and manage simulation workloads on distributed resources. You can set up simulation jobs on distributed resources with easily configurable applications definitions, monitor jobs on distributed resources both graphically and analytically, and manage simulation jobs, visualize remote data, and results. The Compute Manager submits jobs to clusters managed by PBS Professional using PBS Application Services. It uses the PBS Application Services application definition technology to easily define applications for job submission. It saves commonly used applications and application inputs as profiles. It allows to drag and drop files from the remote file browser directly onto applications. Compute Manager Job Monitoring provides a nearly real-time display of all currently running jobs. It allows jobs to be filtered and grouped easily to better clarify the monitoring output, and allows job files to be viewed or edited either prior to job submission or during job execution. Inside of Compute Manager, text and HTML results files can be viewed in the intuitive File Viewer. Results can also be visualized in a variety of different formats using any third-party plugin supported by the web browser. When reviewing results, try out innovative results diagnostics management viewing interactive XY plots in a web browser, along with being able to visualize 3D results using Altair's Hyperview Player plugin. The Compute Manager login screen appears after entering the URL. The username and password are entered to log into Compute Manager. After logging in, the Compute Manager screen appears showing the list of jobs, the results of the selected job, and options for using Compute Manager. To submit a new job, the Job Submission option is opened. For this example, we will submit an OptiStruct job. First, a name is entered for the job that will be run. Next, the billing account to run the job is selected from the list of options. The number of CPUs available on the machine are selected from the menu. For this job, 1 CPU is sufficient. Then, the amount of memory to use when running the job is set using either the slider or by entering the amount into the field. Finally, the .fem file for the job is selected from your machine. The file is selected and uploaded to the machine. Now the job is submitted to perform the run. The job ID appears in the message window. The job appears in the list and is selected to view updates as it runs. The refresh button is used to update the results area with the files as they are written. Now we see the job has successfully run and the results files appear in the Files tab. The job queues can be filtered using the checkboxes in the left column. The Applications box will show the jobs for all applications if selected. If all applications are not needed, a certain application can be selected to filter the jobs for just that application. Also, if you would like to see everyone's queue, deselect the My Jobs checkbox. The queues can also be filtered by job status. In this case, we will remove all the successful jobs. This shows there are currently no running jobs on the server. The successful jobs are shown to review the results of the job run previously. The results are reviewed using the files in the Files tab. The columns can be sorted by time using Date Modified. Additional columns can be added by right-clicking on the fields currently shown, then mousing over the columns flyout menu. Now we see a list of all the available columns that can be added to the view. Now we are ready to view the results of the OptiStruct file. First, we double-click on the .out file. The text file shows up in the viewer to review the results. The file can also be edited in the viewer by clicking the Edit button. The viewer is used as a text editor to edit the file. In this case, we will leave the file as it is. If needed, the Resubmit button can be used to resubmit the job after changes are made. Notice that all the parameters are already filled out and the job can be submitted to run. The resubmitted job runs, and the results appear in the Files tab. Next, the HTML results file is double-clicked to review it in the viewer. The HTML report shows up in the viewer to be reviewed. Double-clicking the .hist file allows it to be opened. The HGData file is opened to view those results. Files can also be selected, such as the .h3d file for download. The Download button allows the file to be saved to the download directory specified in the web browser. The file is saved to the local directory. The file can now be opened in HyperView on your machine. With HyperView open, the file that was downloaded is found. The file is then loaded into session. With the H3D file loaded, the contour of the results can be reviewed. For this example, we will look at the buckling mode. The contour is now applied to the model. Each subcase could be reviewed for the buckling mode. The individual files, the whole folder of files can be downloaded by selecting the Download button. The folder downloads as a zip file to your machine. Files can also be uploaded as necessary to the server if needed. Simply browse for the file and select a destination path for the upload.